Hello everyone, welcome to FA Learning. My name is Rabbi Alam and today I am with a new video with new topics, which is dry pipe sprinkler system. Normally I am going to talk about dry pipe sprinkler system installation as for NFPA 13 requirement chapter 7 7.2 sections, right, which is for dry pipe system. So let's start now. If you have not subscribed my channel, please subscribe so that you can get the latest update on various FA topics in the future. So let's start now. In the previous video with the FA learning, I discussed about wet pipe sprinkler system, right? We discussed about wet pipe system where we have no problem with the freezing. We can use the wet pipe system and it installed worldwide in more than 80 to 85% of installation. But if we have problem with the freezing temperature in some area where temperature always goes in the minus, we don't have any option to go with the wet pipe system, so we have to go with dry pipe system, right, where water freezing is possible. And the next two, which is deluge system and pre-action system, I'll be making another video in my next module, right? So deluge is normally for the high hazard applications, right, where we have only open nozzles, and the meaning of deluge is flood. When there is a fire, detection system activate the valve and water will come from all the sprinkler, making a huge amount of water in a small amount of time, in second, right? And the last one, we have the pre-action system, where concern over water damage, right, where we have concern over water damage, we are using the free action system. So for today, let's stick to our topics, which is for dry pipe system. So here we have a typical image for a dry pipe system, right? This is our water supply all the way. This is our water supply all the way from underground networks. Here we have our riser, right, and then we have a dry pipe valve enclosure, right. This is dry pipe valve enclosure because since we have freezing temperature, we have to keep our riser room in heated area, right, because still we have water up to this point below the dry pipe valve. So if that is exposed to atmosphere, it will freeze, causing the obstruction in the piping like ice, and there will be no flow. So this area should be a total enclosure with heated enclosure, right, to avoid any kind of the freezing. And then we have a gate valve here, right, which is for the isolation purpose. Will come in a while regarding the supervision requirement and all. And this is our dry pipe valve, right? So below the dry pipe valve we have water. After the dry pipe valve we have air or nitrogen. The color in the yellow we have mixed with the air, right? So might be nitrogen or might be air, anything is possible as for the requirement and the ASA applications. And then we have a fire department connection to supplement the water supply to the system in case of the emergencies. And we have a main drain connection here to discharge the water in case of the maintenance, or once the system discharges, we have to put the system back to the service. At that moment we have to use the main drain connection. Okay, then we have a water motor alarm, right? So normally when water starts flowing, those water coming from those water pressure going directly inside the impeller and giving a high pressurized jet, which causing the impeller to rotate and making some alarm, right? So this is how water motor alarm works. And then we have our sprinkler here at the top, right, filled with the air at this moment. At the bottom, at the last remote location, we have inspector test connection, right? So this connection normally for the inspector, he want to make sure that when he opens the this test connection, he want to make sure that what is the time duration in second required to water reach at this location, because in case of that system activation, a sprinkler system fused, first air will go out, and due to the difference in the pressure at the valve, right, at the valve, water will push, and it will push the clapper, and then water will go inside the system. We'll discuss all in detail. This is just a general overview, right? The one in the yellow we have the air pressures, and the one in the blue we have water pressure. This is all about the general layout of that one. So moving on to the next slide. Here we have a typical dry pipe system, right? We have a typical dry pipe system, right? This is our dry pipe valve normally. Okay, so below this one we have water. Let me take some other color so that it can come. Below this one we have water, and below this one we have waters, and after that we have air, right? So how water and air separates, because area at the top side is much more higher than the area at the bottom. We'll discuss in detail in our coming slide with the general schematic diagram. This is the dry pipe valve, and here we have a main drain connection, right, to discharge the water once the system activate, to put the system into the service and maintain the system, right, in case of the maintenance. Here we have a quick opening device. This is a mechanical accelerator with a pressure gauge at the tops, and this is the air connection, supply air connection to that one. The below one we have a water pressure gauge. At the top we have a air pressure gauge, right? And below that one, behind that, you can see the red box. It is a supervisory switch. It is giving the pressure requirement. If the pressure is high or low, air supply pressure, right, it will give some supervisory signal to fire alarm panel, and someone will come and he will look for the cause for that one, right? At the bottom we have a isolation control valve. This is a butterfly valve, right, normally in open condition at this moment, and should be in open condition 24/7, because if it is not open, then water cannot go inside the pipe and our sprinkler system cannot control or extinguish the fire. And most of the case, the failure of the sprinkler system is because of the closure of this valve. So I will be coming in detail at the end of this module, right? So normally if this flapper is in perpendicular to the pipe, parallel to the pipe, this one and this one, it means the valve is open, right? And if it is parallel to the pipe like this, the valve is open. If it is perpendicular to the pipe, it means the valve is closed, and it is supervised. You can see this wire, right? This is wire is going to the fire alarm control panel. If someone try to play with this one, or they want to close or open it, it will send a signal to fire alarm control panel, and someone will come and they will look for the possible cause. Okay, so what is the application of dry pipe system? Where is the application of dry pipe system, right? Dry pipe system installed in the area where heat is not adequate to prevent freezing of water, right? Always where temperature goes in minus, below 0 degrees Celsius, right? So we have to use the dry pipe system at those locations. And what are the areas of the applications, right? We can use the dry pipe system in unheated warehouses, parking garages, store windows, attic space, loading docks, and other area exposed to freezing temperature, right, where water filled pipe cannot be utilized because of the freezing temperature. These are the application of dry pipe application system, dry pipe sprinkler system. Okay, here we have the basic principle of air and water pressure, right? Normally, 20 psi of air pressure can handle 100 psi of water pressure. How it works, I will explain in detail. Look at this schematic, right? These are the area of the air pressure, all the top, right? And the bottom we have the area of water pressure, right? So area A1 is for the air pressure and area A2 is for the water pressure. Okay, This is our resetting knob that we'll discuss in detail in next slide, right? So normally area A1 is greater than A2, if you can see here, right? See the bigger area at the top side, right? This is a big area, and at the bottom we have very small area, right? So we know that from basic science, pressure equals to force of an area, right? Or force equals to pressure into area, right? So let's assume if pressure is constant and A is getting larger, right? Then F will be increased directly. Utilize this formula, right? Keeping the pressure constant, increasing the area. At the end of the calculation, we are going to get more force, right? So that force will be much more enough to close the clapper, right? In order to close the clapper, the force F1, which is for the air pressure at this location, right, and F2, the water pressure, must be equal, right? These two forces must be equal in order to maintain this clapper. This is a clapper, right, in closed position, you know. So now it is system is in service. There is no fire. Air is pressurized at the top of the dry pipe valve and water is pressurized at the bottom of the dry pipe valve. So how it is going to activate? When a sprinkler system breaks in case of the fire from the heat going all the way from the fire via convection and then transferring the heat by with the conduction at the bulb will rise at a certain temperature based on the RTI index and all and temperature ratings. It will damage. Once it's damaged, the air will started coming out from the sprinkler. So at this moment, right, pressure in this side will decrease, and once the pressure decreases, the water pressure will be pushed the clapper and it will open and system will go to and system will activate, causing and it will extinguish or control the fire, right? This is the basic idea. If you can see this equation, right, here we have F1 equals to force F1, right? If A1 is bigger, P1 should be down, or if A2 is less, P2 should be high in order to keep F1 equals to F2. In order to open the clapper, right, the force F2 must be greater than F1. How it is possible? It is only possible when our sprinkler system activate and the air going outside from the pipe, and due to the difference in the pressure, the valves open and controlling or extinguishing the fire. Now, how to maintain the air pressure, right? How to maintain the air pressure and water pressure? Water pressure below the clapper and air pressure after the clapper. This data normally we can get from the manufacturer data sheet, right? Something by if you are buying the dry pipe valve, they will give the data sheet and they will recommend you how to maintain air to water ratios. Normally it is around 5 to 1 or 3 to 1 ratios. Something around, if you can see, this table is for one of the dry pipe valve. They are saying if there we have water pressure of 100, air pressure should be around 25 to 33, in between this range, right? We can keep something in between this range, right? Or if we have water pressure is 80 psi, the air pressure of 20 to 28 psi is more than enough to hold the clapper, right? Because of the difference in the area, the one we discussed just a while ago. So in this schematic, we are going to discuss about how the system activates, and we are going to discuss in detail regarding various components, right? So the first one here we have a main control valve, normally open, right, supervised, and then here we have this is our dry pipe valve, right, and then we have a clapper here, right? As I mentioned that above the clapper we have bigger areas with the air pressure, and below the valve we have water pressure, which is a smaller area. So this is why you know difference in the areas and the pressure differences can hold the system in idle condition, right? In normal condition, the system is in operation and the water is not discharging. It will only discharge when there is a fire and this sprinkler system breaks, right? So the one in the blue at the bottom is supplying is the water, pressurized water, right? We are getting water from the underground fire water networks or from the fire pumps all the way to the bottom of the clapper, right? And here we have a drain valve, right? Once the system activate, if you want to put the system in service, we have to open the drain valve, or in case of the maintenance, we have to drain the waters, because in dry pipe system, the most of the problem with the maintenance comes with the accumulation of water at the low point in the system that must be avoided in order to keep it clean, right? And then here we have a pressure gauge. Normally it is a water pressure gauge, right? It is measuring the water pressure gauge at the bottom. And then the one in the yellow line, yellow color, right? It is air, it is open to atmosphere, right? This is air connection, right? In normal, it's pressurized by nitrogen or air, right? The one in the blue. And then here we have a the middle one, right? The red line, right? The red or violet, whatever say. This line is open to the atmosphere, right? This is not pressurized. I will start with the yellow line first, and then I will come how the system activate. Okay. Assume when the system activate, this sprinkler breaks, and once the sprinkler breaks, air coming out from this sprinkler and causing the pressure to minimize, and then due to the difference in the pressure, the water forces the clapper to open, and hence the system activate continuous in the process. Now when the water activates, water started flowing, we have to get some signal, right? The system activate, we have to get some alarm and some supervisory signal to our control panel that there is a fire at certain location or system activate at certain location. For that we have this line, right? All the way from this line we have a swing check valve in this direction, so it will only go in the forward direction. And here we have a connection to water flow pressure alarm, right? So when water started flowing, it will detect the pressure and it will give a signal to fire alarm control panel, and then it will send signal to some of the annunciator panel or someone who is monitoring those premises, or maybe it will give signal to municipal department or fire or civil defense team. This connection is left, because this is left for water motor alarm, because it's a pressurized water. If you want to put a water motor alarm, there is a connection we can put there and we can get the signal, right? So this is all about this line. And then we have a air gauge, right? Air pressure gauge. We discussed about the water pressure gauge, and we discussed about the air pressure gauge. The difference in between these two is that is something around 4:1 ratios or 5:1 ratios, based on the different manufacturer or different data sheet providers, different valve providers, right? This is all about the working principle of dry pipe valve, right? This is our main drain and this is our low drain system. Okay, so here we have a process for system activation. How system activate? It is a 4-step process, right? First, a sprinkler fuses, just as it does with a weight system, right? Similar to weight system, it fused, and then pressurized air or nitrogen go outside, evacuates, and once the pressure drops below the ratio of the differential valve, right? Below this ratio, right? Discuss this one. If this goes below this ratio, the valve open and allow water to enter the piping and flow out of the open sprinkler, extinguishes or control the fire as per the design requirement. This is all about the working principle of dry pipe valve. And then we have an air maintenance device, right? Normally we need a pressure maintenance device is a pressure regulator that automatically reduces the supply air pressure to a preset requirement when connected to a constantly maintained air supply, right? We are getting air supply from this connection, maybe from the compressor or maybe from the instrument air plant. All the way from this line, the air is going from this one. This is our regulator, right? It's regulate the pressure, and then it go all the way from this line, and this is the connection going to our dry pipe valve. In case this regulator is faulty or some problem we have a bypass line. It's normally in closed position, right? But for time being we can keep in normally open position by opening this valve in case if that is faulty and we have to replace that one, right? And this is a field adjusted air maintenance device. This is all about the air maintenance device, okay? And then we are moving on to the pressure relief valve, right? We discussed regarding the air maintenance device. Now we are moving on to the pressure relief valve. PRV is normally provided with the valve trim is factory set to relieve at a pressure of 45 psi or 3.1 bar. Normally, as I said, 100 psi of water pressure can be held easily by 20 psi of air pressure. So normally the pressure range is, if you can see the table here, the pressure range for the water we have, for the air we have, maximum it is up to 60 to 68 psi, right? So this one is factory set to 45 psi because normally we need around 20 to 25 or 30 to 35 psi for most of the application. But this value we can reset, we can reset at the field, right? This PRV may be reset to a lower or higher pressure, right? How you are going to reset this one, I am going to make another very short videos regarding the component of that. We have to loosen this one, and if you are going anti-clockwise or if you are going clockwise, the pressure will go higher or down. We have a data sheet for that one from the Tyco. You can easily refer to that one. Now these pressure settings may be set as per the requirement of the ASA or it is having jurisdiction, right? Because they are the one at the end of the day they are going to enforce those facilities, right? So it's up to them. And then we have mechanical accelerator, right? We have a mechanical accelerator here. We have a mechanical accelerator here, right? When the accelerator trips, it transmits air into differential chamber of dry valve, which in turn negates the differential within the valve, allowing water to flow into the system, right? Normally, different mechanical accelerator, it speeds up the operation of dry pipe valve when they detect that there is an air pressure drop at the rate of more than 1 psi per minute. So mechanical acceleration required as for NFPA 13 7.2.3.3, right? 3.4, not 3.3, because if our capacity is below 500 GPM, we don't need a QOD device like quick opening device. But if our capacity is 750 GPM or between 500 to 750 GPM, we need a quick opening device, to speeds up the opening of the valve and sending water to the most remote activated sprinkler as soon as possible. Normally there is 60-second time to reach the water to the remote location. We'll come to that in a while. Then we have a main control valve, right? We have gate valve and we have butterfly valve, right? It must be supervised. The gate valve is supervised by a tamper switch, right? A tamper switch, normally a rod which is put inside the stem. This is the stem, right? So how you are going to identify the valve is open or closed? Because most of the time the failure of sprinkler system is because of the closure of the control valve, because someone doing maintenance and at the end of the day he forget to put the system into the service, right? It happens because most of the losses happens because of the failure of the sprinkler system. Research found that there are mainly because of the closure of the control valve. So if it is supervised, if someone is closing or opening this one, it will give a signal to the panel and it will give some supervisory signal, and they will come and they will check what is happening. Now how you are going to identify the valve is open or closed, right? Look at this system, right? If it is outside like this one up to this hand, it means valve is open. At this moment this valve is closed because this system is totally inside, right? If it is outside this rod, this system, we call it system, it comes up to this point, means the valve is open. At this moment it is closed. And if you are closing the valve, right, you are not allowed to close this valve in less than 5 seconds because of problem with the water hammer. Water has a force, suppose 150 psi force coming, and suddenly you are closing the line. Where should that pressure surge just go, right? It must be go somewhere, let's say at the fittings, corner, elbows and T. It might leak or it might break. It might damage the hangers or it might damage the integrity of the fire protection system. We have to be careful that our system's control valve cannot be closed within 5 seconds to avoid the water hammer. Now the next option we have the butterfly valve, right? These two are the control valve, right? Because butterfly valve, sometime, you know, if we have a space limitation in the mechanical room, in the riser room, we can use the butterfly valve instead of the gate valve, because the butterfly valve will take less space compared to the gate valve. You look at this one, this and this height, and compared to this and this height, right? It's much less, right? So it takes small areas, a small space for installation. Now it is also supervised by this wire. If someone is turning it on, it will give a signal. And how you are going to identify? This is an indicating type butterfly valve. Indicating means we have a yellow flapper here, right? Normally if it is parallel to pipe, this is our pipe, right, and it is now perpendicular. If it is perpendicular to pipe, because it is perpendicular to pipe, it means valve is closed. If it is parallel to pipe, something like this one, it means valve is open. At this moment it is closed. Just for information, all the requirement of the closure in 5 seconds, supervision and indicating should apply in the butterfly valve also. The basic difference is regarding the space requirement and the supervision and indicating type. That's it. Okay, moving on to the pressure gauge, right? Since we are working with the dry pipe system, we need to monitor air pressure as well as water pressure, right? If you can see here, we have a water pressure gauge and here we have a air pressure gauge. Normally the pressure gauge should be at least 2 times the design pressure, right? So we have a 300 psi, and we know that water-based fire protection system maximum pressure should be something around 175 psi in most of the case, and the air pressure is around 80 psi, right? So where we need pressure gauge, as per NFPA 13721, approved pressure gauge shall be connected as follows, right? It should require at the water side to give the water pressure in the dry pipe valve. At the air pump supplying, there is air receiver where one is provided, right? Normally at the air pump supplying unit, right? And then at the receiver where one is provided in each independent pipe from air supply to dry pipe system, and at quick opening device, right? Not mandatory that all these requirements should meet. Sometimes it might be only the 4 places. Let's go to the figure back. We can discuss regarding those pressure gauges, right? Look at here, we have 3 pressure gauges. This one is for the water, this is monitoring the air pressure, and this is the air pressure for the quick opening devices. So here we have 3, and one should be at the supply riser, right? One should be at the supply compressor to make the to read the pressure requirement. Okay, so we discussed regarding the pressure gauges. Now moving on to the next topic, we have the main drain valve and water flow alarm switch, right? As I mentioned in the beginning, main drain valve, we need to remove the water once the system discharges, or in case of the maintenance, we have a main drain valve. The size of the drain valve should be as for 816-242, right? Up to 2 inch we have 20 mm, and between 2.5 inch to 3.5 inch we have 32 mm, and 4 inch or larger we need 2 inch or larger drain connections, right? The main drain valve we discussed in the beginning. And then we have a water flow alarm switch here, right? Once a sprinkler system activates and flow begins, at that moment it will give a signal to the supervisory signal that water is flowing and system activates, so that someone will come and look at, they will extinguish the fire, or they will find the possible cause if it is faulty activation, right? Then we have a auxiliary drain valve, right? We call it collect and drain auxiliary drain valve, right? To use to drain excess water from the system. Normally, with the dry pipe system, we have the major problem with the corrosion of the piping. Once the system activates, and if at some location, at some lowest spot, if water is there, those water can mix with the oxygen, right, in the air, and they can damage the internal piping. To avoid that one, we have to be careful regarding the drain connection. We must design our system in such a way that all the water discharges completely after the activation or during the maintenance, right? So the purpose of this collect and drain valve is that we want to remove water only while maintaining the air pressure. How we are going to do that one, right? Suppose this is connected to the system, the pipe system, right? And this is the drain connection, right, in the dump. So first it is closed now. We'll open this one first, and once after some time all the waters come here, we'll close this line, and then we'll open this one. We'll repeat this process one by one until we found that there is no water droplets coming from that one. And for more information, you can go and look for some videos of auxiliary model 5300 from this manufacturer, right? And you can get more information from that one. This is basically for avoid the loss of the air pressure while discharging the water after the discharge or during the maintenance process. Okay, so how we are going to supply air to the system, right? We can supply air from the compressor unit, or there is some riser wheel compressor also, like here we have, right? This is a riser mounted compressor, right? So it's based on the design at the requirement. If you are installing in a plant where we have instrument air, right, air available easily, then at that moment you might go with this solution, right? Not with this one, because it's very complex and we require lots of maintenance issues. It's costly, compared to some other solution. But again, it depends upon design to design and at various location or requirement, right? Air pressure supply must be maintained, and it must be restored within 30 seconds, right? It must be restored within 30 seconds means we have to calculate the total volume of pipe after the dry pipe valve, right? Total volume of the piping which is exposed with air or nitrogen, and that should be filled within 30 minutes, right? And how you are going to pipe, I have not covered that one in this module. You can go to 7.2.3 of NFPA 13, right, which is the size of the system. Normally they have given a table, right? Based on the table, they want to make sure for 1 feet of the pipe, what is the capacity in gallon or liters. You can found that one, right? So coming to the topics now, right? Within 30 minutes we have to restore the supply, right? Shall be soft air supply or from automatic compressor. We can use anyone. Air pressure shall be maintained 1.4 bar above calculated trip pressure or as per instruction sheet, right? Suppose your system is your system requires 2 bar, then the capacity of the air pressure shall be 3.4 bar, something like that one. But you have to follow the data sheet of the manufacturer, because it varies. This is the minimum requirement from the NFPA, but you have to look for the data sheet also along with this one. That's all about the air supply. Now moving on to the system configuration, right? What system we are going to use? 72310 of NFPA 10, NFPA 13 talked about that we cannot use gridded dry pipe systems, shall not be installed, because with the gridded system there will be multiple number of flow points, right? Multiple number of flow point the water can take to fill the grid, and because excessive amount of air can trap in the system, it will delay the activation of the system. Remember, 60 seconds is the time set by NFPA 13 to reach the water in most of the case. So with the gridded system we have the problem, right? Suppose we this one activated, right, and water is coming from this line and water is coming from this side also and from this side also, right? Water is going from this one and going from this one. So we have multiple part of water, right? And in that case we have excess amount of air filled. It will delay the water to reach at the origin of the fire, causing the fire to grow much more larger than the design capacity of the fire pump. Remember, we have to select only a design area for a sprinkler system, and based on that we have to size the piping and select the pump and tank size. So gridded system we cannot use because of those delay in the water reaching the most remote location in case of the fire. So we have two options. We can use the looped configuration or tree configuration, and combination of looped and tree is possible, right? So gridded configuration we cannot use. Okay, now moving on to the sprinkler system, right? Which kind of the sprinkler we are going to use? As for 7.2.2, these are the following sprinkler we can use for dry pipe system. Upright sprinkler we can use the listed dry sprinkler, right? And pendant sprinkler and sidewall sprinkler installed on return bends, where the sprinkler return bends and branch line piping are in area maintained at or above 4 degrees Celsius. We have to make sure the system doesn't freeze, right, in the pendant case or any, so we have to avoid that one. So what is the point of talking the return bends? We'll discuss in next slide in detail, right? Just wait a moment. And horizontal sidewall sprinkler installed so that water is not trapped. We have to make sure water is not trapped in the system anytime, because it is mixing with oxygen, causing internal corrosion, which can damage the piping very short duration of time, right? So what is the reason we cannot use the pendant sprinkler? We know use of pendant sprinkler allow a small amount of water to remain on the seat of sprinkler, right? Seat of operating mechanism, and this water could freeze and impair the sprinkler system, right? Can freeze and impair the sprinkler. Therefore, pendant sprinkler is not permitted. However, if it is necessary to use a sprinkler in pendant position, right, 7.2.2 permit use of listed dry sprinklers, right, as an option, right? So dry sprinkler prevent water from accumulating on sprinkler mechanism and in drop nipples. So I'll make another video regarding the dry sprinkler and this return bends, so that we can have a look at that one. Just wait for my next video. Okay, last but not the least, right, it is much important to the sizing option, right? How we are going to size the sprinkler system. So for the dry pipe system we have 5 different types of the sizing option, right? 7.2.3.2 talks about 60-second water delivery, right? We have to confirm that the water reaches within 60 seconds in 7.2.3.2. What they are talking in 7.2.3.2, right? System size shall be such that initial water is reached to the most remote locations, most remote test connection, right? In this case, let me go to the first phase so that we understand the test one, right? To this connection, right? In 60 seconds, this is the option 1, right? We have And 7.2.3.3 talks about if the capacity of the system is 500 GPM, 500 gallon per minute, those 60-second requirement doesn't apply for that one, right? A system size of not more than 500 gallon shall be permitted without a quick opening device and shall not be required to meet any specific water delivery requirement. Those 60-second requirement doesn't required for 500 GPM or less capacity as for 7.2.3.3 without quick opening devices, right? The next option we have 750 GPM. And now if your capacities is between 500 to 750 GPM, right, we need quick opening device like the mechanical accelerator we discussed in the beginning, so that it will accelerate the opening time, accelerate the air pressure from the bottom of the clapper, and it will open it fast. So if your size is 750 GPM or like that, you will have to use a quick opening device. Then option D we have 7.2.3.5 talks about water delivery calculations, right? So here we can system size shall be based on dry pipe system being calculated for water delivery in accordance with 7.2.3.6. Now 7.2.3.6 talk about a table, right? We'll come to that table in our in next slide, right? And the last one we have water delivery to test manifold as for 7.2.3.7. So these are the requirements. So water delivery calculation in point D as for 7.2.3.5, right? They talks about they are referring to a table. Here is our tables, right? Now this table is for option C, right? In the previous slide, option D, sorry. This is for option D, 7.2.3.5. Now here we have water delivery time in second for different types of hazards, right? Light, ordinary 1 and 2, extra 1 and 2, and high file. If you want to get more information regarding hazard classification, right, I will recommend you guys to check out my video on hazard and commodity classification. A 40-minute videos will explain everything regarding the those hazard classification and commodities classification, occupancy classification and commodities classification in detail, and I will put the link in the description box so that it will help you. So for the light hazard, right, at the most remote sprinkler initially open is 1, right? In the light hazard case, if one sprinkler activate at most remote locations, water should reach there by within 60 seconds, right? Not more than that. If it is ordinary 1, 2 sprinkler opens and water should go within 50 seconds, right? All the way for the extraordinary to the same. For the extra hazard, 4 sprinkler activated and the time in second is 45 seconds. If it is high file, 4 sprinkler activated and delivery time is 40 seconds. Why time in second decreases for the extra hazard? Because extra hazard occupancies has high heat release rate. So in just around 20 to 30 seconds, there will be much more heat that will break more than one number of sprinkler. For extra hazard 1, 2 and high file, they consider that maybe 4 sprinkler or maybe more than that sprinkler activate, causing the air to move faster from the pipe, evacuate faster from the pipe, and then they have set the timing requirement. So this is all requirement for sizing option. Option A 60 seconds for 7232, B, C, D we discussed, right? But these are not applicable for the dwelling unit, right? Suppose the dwelling unit as for NFPA 13D, right? If you are installing the dwelling unit as for NFPA 13D or 13R, because those are for the life safety protection, right? So we should water should reach in that areas within 50 seconds, not more than that. So keep in mind, this is only for NFPA 13, not for 13R or 13D. Okay, the last one we have discussed so much about the dry pipe valve. Now let's talk about some of the disadvantages of this one. Of course, if we don't have any option to avoid the freezing temperature like antifreeze solution and all, we have to use the dry pipe valve. But The first disadvantage is it's increased complexity, right? We see there is lots of component right here. There's lots of components, equipment and all, it's very complex, very costly, and it's look at more installation cost as well as maintenance cost, right? Lots of the maintenance issue will be there along with this one, right? Option B, higher installation and maintenance cost. We discussed that one. Option C, we have lower design flexibility, right? Remember we discussed a while ago here regarding the capacity is 500 GPM, 750 GPM and so on, and the time in second to going all the way from the dry pipe valve to the most remote locations. Now it has lower design flexibility, right? Most of the regulatory requirement limit the maximum perimeter size to 750 GPM of individual dry pipe system unless additional component and design efforts are provided to limit the time from sprinkler activation to water discharge to under 1 minute or 60 seconds. It should be reached to the most remote location within 60 seconds. Now, option D talking about increased fire response time. If your system is larger than 750 GPM and the size of the piping is very big, so in that case, it increases the fire response time. We have to achieve within 60 seconds without any problem, right? And the last one, it increases the corrosion potential, right? Because I discussed that when water and oxygen meet, it will damage the internal piping and it will corrode very fastly. So this is why dry pipe system need more maintenance and a higher knowledge to design those systems. We want to make sure that our dry pipe system is designed in such a way that all the water discharges after the activation or after the maintenance issue. If there is a water inside that one, it will cause corrosion and it will decrease the efficiency of the system, and it may be obsolete maybe after 5 years, because corrosion is very tough for those metals and all. We have to be careful regarding that. Moisture plus oxygen increase in internal pipe corrosion. And then we have the fire department connection, right? It used to supplement the water supply to the system, right? Here we have this is our fire department connection. It is connected to the header or valve room. We have a check valve going in the forward directions, right, all the way to this one, and this is going to a riser room for the dry pipe system. Now the purpose of the fire department is to supplement the water supply, but not necessary to provide the entire sprinkler system demand, right? And here we have 3 requirements for that, right? We can exclude the fire department connection with 3 requirements. The first one, if the building is located remotely, our fire department team cannot go there. So if our fire department team cannot go, what is the use of that one, right? We cannot install. The second one, if it is used for the second is not applying here because the second is for the deluge system, right? So forget about that one. The third one, the second one, the next one I mean, is for the maximum area of the room. The area size is 1 story only and something like less than 185 square meters. We can exclude that one. Okay, now we have the maximum protection area as for 8.2 of NFPA 13s, right? The maximum floor area can be protected by 1 sprinkler riser. For the light hazards, we have 52,000 square feet. Ordinary, same values. For extra, we have 40,000 square feet. And for storage, high file storage as for 3.9.1.16. Now 3.9.1.16 discuss about the definition of high file storage and all those arrangements. So this area can be maximum of 40,000 square feet. If the values of the area more than that, we have to install separate risers for those areas. We have to divide zone by zone and then we can come to a solution. Okay, so here comes to the end of this module, right? I hope you guys learned something from this one. If you like the content, please subscribe my channel and share so that someone can get help from this one. And if you have any doubt, suggestion or comment, you can connect me through the LinkedIn or you can follow my page on Facebook. My page is Learn FPA. Thanks for your time consideration, and I hope you guys are enjoying this module, right? And I will see you next time with a next video. Most probably, I'm going to discuss about deluge system, because next to deluge and protection system, after that I'll be going to some another modules of fire protection engineering, right? So stay updated, stay connected, stay safe. Take care, guys. Bye bye. See you next time.